Yeah, all right. Got a camera install this week, and I have bought one of these Northern power supplies. And it's the first time I've bought one of the Northern power supplies that come in a can and come with a transformer and all that. Who knows? We'll see. I haven't opened it up before and actually taken a look at it. I needed 4 channels and for cameras, and I was going to run a couple of fans off of one channel, and I had intentionally just buying a 4-channel Altronics, and Altronics is great. They make great products and they make great power supplies. I carry a couple of their products, the SMP3 and the SMP5, with me all the time. But I thought I'd give one of these a shot. I actually use a couple of the Northern smaller 4-channel power supplies that just have like a big transformer and then 4 individual outs that are probably like thermally protected, but they're not fused, and just has a little 3-pronged whip that you plug into the wall. And I use those here at my house and I like them. So I was going to give one of these a shot because they were out of the 8-channel Altronics. So let's open it up and take a look and see what it does. Alright, so that's what it looks like out of the box. Let's go ahead and open it up. Here's a brief look at the instructions. So that's cool. It comes with the basic instructions on the front, which you would pretty much expect to have in there. The one thing I don't like is that they did not leave a blank spot over here so you could actually label the channels 1 through 4, but it looks like, or 1 through 8 in this case, but it looks like maybe you could either just write them in marker on this if you didn't plan on making this into a 16-channel or adding more channels than this. So it's pretty much what you expected to see. I actually bought another power cord anticipating that it wouldn't come with this, so that's a nice feature that it comes with. Comes with a lock and a set of E005 keys, which is a common key in the alarm industry. So everything looks good there. It looks like a pretty big power supply. I was gonna see if this RF shielding came off so we could just take a quick look at it. Looks like I'm about to void the warranty by doing that, but you know, sometimes you just gotta take a chance. Got to be smarter than the power supply. Crap. Had to go out to the truck and grab this little stubby. It's a little Klein screwdriver that has a small shaft and a small handle, and is made for tight spaces. I think it's got, let's see, I think those that's a 5/16 nut driver. And then it's got big Phillips, big flat, small Phillips, small flat. So I don't think that's going to fit, but the point of me doing this is the way that they've got the power supply in here is it's looks like it's stuck with an adhesive. So if I want to look inside it, i.e. void the warranty, then I've got to take this off. So this little RF shield just pops right off, and that's obviously how you access the 220 to 120 switch, which is kind of nice. I didn't know that it had multiple input voltage. 220, 110. And I'm not an electrical engineer, and I'm definitely not a switch mode power supply guy, which is what I would assume that this is. So I'm just going to do a little close-up in case anybody's interested in the design, and you can figure it out for yourself. Looks like it's got a couple of smoothing caps there. The brand name is Dongbaohe. Dongbaohe. I can't say I've ever heard that brand before. It could be the best brand there is for all I know. And then Everything else looks like it's in place, and again, I'm not in a double E, so I can't tell you exactly what's going on here. All I know is big power go in, small power come out, and that's pretty much it. So we've got 120 volts being stepped down to 12 volts step down and being rectified. It looks like maybe the bridge rectifier is here, or maybe there. It's one somewhere around there. So anyways, and it looks like this is fused as well too, but it looks like that fuse is not easily replaced. It has it appears to be soldered in there, and that's it. I don't see any brand name on the board, but you can't see anything with my big head in the way. So I'm not sure if that's actually built by somebody else or not. I'm sure that it is. We'll put the RF shield back on and turn it on and do a couple tests. That's the screw that I was getting out, and all I did was just take the bit out of the screwdriver and twist it out. It's pretty easy to do. I had to break it with a pair of needle nose pliers, but getting it back in there, it's finger tight, is okay. It's not going to move around or vibrate. Once I get it installed, we'll just mount this other screw back in there. So it looks pretty straightforward. We've got our 120 volts incoming, and I was just double checking to make sure that I didn't actually switch it over to 220 and not back to 210. Maybe damaging something. I'd probably damage something the other way if I was supplying 220 to it. But we're here in the States, and we got 120 volts. So here's what's on the edge of the power supply. We've got our incoming voltage, and then it looks like we've got our rectified step down power coming out, and it looks like you might actually be able to get more than 12 volts out of this. They've got a negative rail and a couple commons, so you may be able to get 24 volts out. Oh, that's not a negative rail. Sorry, I was looking at it through my monitor, and I thought that that was a negative sign. So you got two positive rails, two commons, so maybe you can get 24 volt DC out of this as well too. As you can see, it's set up with just two of those terminals being connected going into the terminal block over here. So there's 120 volts coming in, it's being rectified and stepped down to 12 volts DC, and then we've got a voltage divider in essence over here with 8 outputs, and it looks like a total power of 8 amps is what this transformer will supply, and these are fused at, well, I can't believe that it's 3.5. Looks like each one of these fuses are 3.5 amps. So obviously if you were to pull 3.5 out of each one of these, you'd be at 24 amps, and this is rated at 12 volts, 8 amps. So I guess you're going to have to be cautious there. I'm not sure why they would put that big of a fuse in here. You would think that you'd put an amp in each one, considering it's an 8 amp output. Let's do a couple of load tests and a couple of standing voltage tests and see what we got. I energize this transformer, and as you can see, it's got a LED that's telling you that it's on, and it's just labeled, looks like just LED, maybe LED 1. So that's telling us that we've got power. Let's go ahead and check our incoming voltage. So we got 120 volts, and let's just double check, see what we got. Okay, so we got 120 volts incoming, and we've got wasn't sure what meter I was using there for a second, and we got 13.4 output, so that's probably going to be 12.8 once you put it under a load. But let's see what we can take this up to. So we can take it up to 14.1, and we can take it all the way down to 10.7. I don't know necessarily why you would want to do that, but just know that the flexibility is there. As parts wear, I think wear is the wrong term for it, but as these parts, components break in over time, you would imagine that you may need to increase the voltage or possibly decrease the voltage if a resistor is a little bit out of tolerance as time goes on. So it looks like we've got 12 volts going out, and that is, I'm just going to call it terminals, you can barely see it over here, I'm just going to call it terminals 2 and 4. So that's a common and a positive rail. So let's see what we've got on the second common. So it's the same thing. Let's see what we've got on this voltage. So that's the same thing as well too. So there may be a combination that you can run that'll get you a different voltage. Maybe you can run those in series and get 24 volts. I'm not sure if they're separate outputs or they're just electrically the same. So that's what we're looking like coming out of the transformer, and I adjusted to show you that. And what do we got over here? We should have the exact same 13.8. 13.5, is that what we got here? 13.5. Yeah. Okay, and there's no load, so that's exactly what we expect to see. Looks like all the housing and everything is exactly what you would expect quality-wise. It's got a little strain relief, probably for the power cord, and this is probably just the same box that ELK and Altronics and everybody else use, and it's exactly what you would expect. De-energize it for a second. Probably should have looked at this first, but I was thinking that that big transformer was actually taped down. It sounded like it was taped down, but it actually looks like it's kind of screwed down, using this whole back plate as a big heat sink. It's got one knockout in the back, and then it's got all these pre-drilled holes or pre-blown holes for different modules, different power supplies, and then your mounting holes. Knockouts on the side, 1/2 inch or 3/4 inch. Same thing on the top, same thing on the side, same thing on the bottom. So exactly what you would expect in a transformer. So let's do a little test and see what we get coming out of this. Let's load the circuit and see what we get.